So after we finish chapter 5, we have a new chapter. In chapter 5, we talk about what is a discrete distribution, and we also learn a very special discrete probability distribution, which is called a binomial distribution. And in this section, we will focus on what is normal probability distribution. So first chapter, we will talk about the standard normal distribution. So first we should learn what is called standard normal distribution, right? Because he has the word standard. So basically all of the normal distribution have the same shape. We call it bell-shaped curve. So all the normal distribution follows follow the bell-shaped. Of course, the standard normal distribution also is a bell-shaped curve. But why it's a special one? It's a standard one because it has this one. The mean value for this distribution is equal to 0. Mean value should be 0. And another important property for standard normal distribution is the standard deviation is equal to 1. So the normal distribution with 0 as the mean and 1 as the standard deviation, we call it a standard normal distribution. And in this section, we will need to know how can we find the probability, because here we will use the scale to find the area under a curve to help us find the probability. And we also need to learn the z-score corresponding to the area under the curve. So first, if a graph of a distribution is a bell-shaped curve, we call it normal distribution. So basically, you only need to know bell-shaped curve. So we know what is bell-shaped curve. It's symmetric, right? So this kind of shape, we call it bell-shaped curve. Any distribution follow this curve, we call it normal distribution. Of course, the mu is in the middle, right? So this is our mean value. Should be in the middle because the curve is symmetric. Before we talk about the normal distribution, we first check another continuous distribution called the uniform distribution. But why we should learn this special distribution? Because this one will help us understand the relationship between the area under the curve and the corresponding probability. So first, let's check uniform distribution. So the properties are the area under the curve for any continuous distribution is equal to 1. The area under the curve for any continuous distribution. We are no longer talking about discrete distribution because here uniform distribution and the normal distribution, they are continuous distribution. So the property is just for continuous distribution. The area is equal to 1. And there is a relationship between the area and the probability. How can we find the probability? We can just find the area under the curve. So for the uniform distribution, the area is just a rectangle. So how can we get the area of a rectangle? We only need to use this formula, height times the width, right? So if we know the area, it's just the probability. We will check the example to help us understand. And the graph of any continuous probability, we call it density curve. So any total area under the curve exactly 1. This is just a definition. Okay, you only need to know this is called the density curve, and you should know the total area under the curve is exactly 1. And you do not have to know why. Okay? And you do not to know how to write the density function, something like that. It's not required. You only need to know the area for it. It is just 1. And you all should know there's a correspondence between area and the probability. We find the area under the curve, we find the probability. So let's check this example first. So in this airport of New York City, passengers arriving at the checkpoint have the waiting times uniformly distributed. So we already know all the waiting times follow uniform distribution. And we also know it's from 0 to 5. It's from 0 to 5. So we already know the minimum waiting time is 0 minutes and the maximum waiting time is 5 minutes. So, and the most important part is the waiting time are uniformly distributed. Now we can try to draw the uniform distribution density curve. So this graph is called the density curve for this uniform distribution. And we know the minimum is 0. The maximum is 5, right? So we list 0 and 5, which means the waiting time in minutes. So the minimum value is 0 and the maximum value is 5. And we know it's uniformly so distributed, which means by the definition, all the probability should be the same. Uniformly distributed. So all the probability will be same. So this this vertical line means the probability. And the probability should be same for all the values from 0 to 5. So I will put a line here, a horizontal line to represent. But we already know this 0 to 5, so is our horizontal line. But how can we figure out the height of the vertical line? 0.2. How can we get this value? Because we do not have this value in our problem. The value we have is just 0.5. But remember, this is a density curve for the continuous distribution. So the total area should be equal to 1. So we use this property to get the height, 0.2. Because we know the height times the width. How can we get the area of a rectangle? Height times width. So height times width is equal to 1, right? The total area. And we know the width is 5. 0 to 5, so the width is 5. Of course, we can get the height is 1/5, right? That's how we get 0.2. That's how we get the height here, because this is the probability. So waiting time can be any value between 0 minute and 5 minute. So it's possible to find this kind of waiting time, right? Because it's continuous distribution. Any value. So it's something like the value here. It's 1.23456. Any value is possible between 0 and 5. So this step show you how can we get to 0.2. You can easily just use this one to get 1 over the range is our probability here. So 1 over 5. Now we have this question. We try to find the probability one randomly selected passengers has a waiting time at least 2. At least 2. At least 2. How can we find the probability? Remember, we have the relationship between the probability and the area. So if this time we want to find the probability at least 2 minutes, which means we should find the corresponding area. First, we locate 2 minutes. 2 minutes. And we know the first step we should locate the value, right? 2 minutes. The second step we should know we set. So we locate the 2 minutes, we set our bar here. We set our bar here. After that, we should determine the area, the direction, at least, which means it's 2 or more, greater than 2, right, or equal to. So we focus on the area to the right side. To the right, at least means to the right, because it's 2 or more. So we goes to the right side. Then we can shade it the area we need. We shaded the area we are interested in. Next step, we only need to find the area of shaded part. That is the probability we are interested in. Okay, so how can we get the area? We just check this small rectangle. We still use the same formula to get the area of a rectangle. The height, 0.2. times the width. So here is 2 to 5, it's 3. So we get the area of shaded part is 0.6, which means so here we already find the area, which means the probability of waiting time of at least 2 minutes is just 0.6. So for any continuous distribution, how can we find the probability? We always check the corresponding area. The corresponding area is just the same thing as the probability. So for this case, we find the single value 2 minutes here. And we determine it is at least, so means go right side. So we focus on this right side. So this is the interpretation. The probability is 0.6. Now we go back to our standard normal distribution. Remember, the uniform distribution is not our final goal. We will focus on the standard normal distribution, but uniform distribution just help us to understand the relationship between the probability and the area under the curve. Because standard normal distribution is also a continuous distribution. We have the same rule. The area under the curve is just the probability we are interested in. But this time, it's not a rectangle, right? It's a bell-shaped curve. How can we get the area under the curve? Because we do not use calculus to help us to get to the area under the curve. We can use table. So basically, let's check what is normal distribution. We already know standard normal distribution is a bell-shaped curve. But if we're talking about standard, we also need to follow these two properties. Mu is equal to 0 and sigma, standard deviation, is equal to 1. But remember, for all the continuous distribution, density curve, the area, total area under the density curve, so the total area here under the curve is equal to 1. We can find the probability or the area. They are just the same thing. We use the table or technology, of course. If you have the advanced calculator, it's still possible to get the area, right? But we will focus on use the table here. Table A2 is our Z table. Is our Z table. So let's check how can we use the Z table. So first we should understand some essentials of this Z table. First of all, only for standard normal distribution. It's just for Z table, it's just for standard normal distribution, not for general normal distribution. If it's standard, so we should follow. Again, mean is 0, sigma is 1. And for the Z table, we have 2 pages. We have 2 pages. And the first page, we have negative Z values. And the second page is the positive Z. Okay, you can find your Z table in your textbook. In your textbook, you have the Z tables. If you're missing, maybe your textbook is a used textbook and the tables are missing, don't worry. You can find your Z tables in the content. I will post the Z tables or any other tables you will need in the content. You can print them out to use the Z table, because you will use the Z table for your quiz, for your exam. Okay. The last one, I would say it's very important. You should understand. Maybe this property is not the same as your previous course. The body of the Z table is a cumulative area from left. I know maybe you have other course talking about the Z table. In their Z table, maybe the area is cumulative to the right. But in our course, the table only shows you the cumulative area from the left. I hope you can understand. It's just from the left. And don't mess up with Z-score in the area when we check the table. Z-score is just the distance. It's just your horizontal scale. And area is the whole region under the curve. So it's the body of your table. I would say Z-score is just the margin of your table. So it's just the leftmost column and the top row. It's just the margin. And the area is the body of your Z table. And the part of the z-score can be found across the top row. The top row only shows you the hundreds. Again, this one help you understand what is z-score. Okay, z-score is just the horizontal line. We label different z-score on the horizontal line, and the area here, the area, so which is the body of your z-score. Z-score is just the horizontal line. So in your table, it's just the margins. So for example, if we have a z-score equals 1.6, you can find the cumulative area from the left is 0.975, something like that. Let me check the tape. Yeah, it's correct. It's just, if in your table you need to find the z-score is equal to 1.696, you will find the corresponding value is 0.975, which means z here is 1.696, and the area to the left is 0.9750. Of course, we can also find the area between two z-scores. We only need to check the corresponding area, then find the difference. We will find the area between two boundaries. We will talk about it later. So, bone density test. This is our example. So in this example, we know all the results as a z-score, which means all the results is normally distributed and also follow standard normal distribution, because here we know mean and the standard deviation. So we can say the test result meet the requirement of the standard normal distribution. This just tells you the background. All the results follow the standard normal distribution. So if it's standard normal distribution, we know it's bell-shaped curve, right? And we want to find the probability the person has a score less than 1.27. So we already know the test score is just the same as the z-score. So we can say this is our test score, Z. So we list C. Here you see the mean is 0, is right in the middle. So we can locate 1.27 about this position. Okay, 1.27 is just about this location. So we first write our z-score 1.27. Then we draw a bar here, right? After that, we should determine the direction. Because here is less than. Remember, if we're talking about a less than, it goes to the left. So we shaded the left part. This is the area we are interested in. So we need to find the area of this shaded part. How can we find it? We check the z-table. Z-table. Because this z is a positive z, we need to check the positive z-table. So you check the positive Z table. We should know how can we check our Z table, because you will use the Z table in later chapters. We will always need to check the Z table. So first, when you check your Z table, listen carefully. You need to find the left column. First of all, we go to the positive Z table. And we only check the first two digits, 1.2, on your left column. From top to the bottom, you will find 1.2. Okay, you will have the whole row for the 1.2. Then we check which value in this row is 1.27. Then we check the top row. The top row we have 0.07. 0.07. Then we check that column, 0.07, and 1.2. We can locate the value. Which one is for 0.27? So first, check 1.2 on the left column. Then check 0.07, because the last digit is 7. So check the top row for 0.07. Then you can find the two lines crossed at 1.27. And that value in your table is the area we're interested in. Let's check if we have, yeah. So basically, this is the part of your Z table. First, you need to check the left column. From top, we have 0.0, 0.1, and so on. You check this row, 1.2, right? First two digits, 1.2. And we have 1.27. So for the last digit, 0.07, we check the top row, very top row. We have this, 0.07, and we can find these two values cross at this one. Cross at this point, right? And this value is what we want, 0.8980. This is the area cumulative from the left, and this is also the probability, less than 1.27. So this is just the area. We get this area from the table. Again, how can we check the table? Make sure you check the Z here, because Z is 1.27. First, we check left column for 1.2. Then we try to check the top row for 0.07. After that, you can locate the value we need. In this case, it's just the value. After that, we only need to interpret our result. We know the probability below this one, because it's the area to the left, right? Below, it's 0.8980. So this is our interpretation. We can say the probability is this one, and we can say about 90% of the people score below this 1.27.